Alright everyone, welcome back to the day 20 of our daily leetcode challenge, and today we have got first completely painted row or column. So let's try to understand the question. In this question what they have provided us is with the m cross n matrix. This is our m cross n matrix having m row and n columns, and each of these and the values in this matrix range from 1 to m cross n. So meaning in the case of this example we have a 3 by 2 matrix, so the values will be from 1 to 6 and all the values in the matrix will be unique. And what the other array that they provided us is the order in which we need to paint these cells having these values. So we need to paint the cell having value 1, then in the other index you have to paint this cell having value 4, on the second index you have to paint the cell having 5, and so on. What they want us to do is they need us to find at the first index at which the entire row or the entire column gets painted. So if we take a look at this example, they need to find that we need to keep painting in this order 0 1 2 3 5 6 4 4 5. These are the indexes. They want us to find the first index at which the entire row or the entire column gets painted. So let's take a look at this example and start coloring these values. The first value that we have at index 0 is 1, so 1 gets painted. At index 1 they have the value 4 to be painted, so we paint this. Now we found that the value at index 1, at the moment we reached index 1, we saw that the entire column right here got painted. So that's why we return 1 in this case. Like at index 1 we found that the entire column that we had here got painted. So this was the case in this example. Let's take the bigger example they have provided us here, which is this 3 by 3 matrix that they have provided here. Let's take this as example and we'll draw this out and see why the answer is 3 in this case. So this is our matrix right here, and let's fill in the values now. We have a 3 2 5 1 4 6 8 7 9, and the order in which they want us to color these values are 2 8 7 4 1 3 5 6 9. Now let's start coloring these values. So firstly we need to paint the value at index 0, which is 2, so I painted this as 2. We painted this as 2. Then comes 8, we painted this. Then comes 7, we painted this value. Then comes 4, we painted this. The moment we reach the value at index at value 4, which is 0 1 2 3, we saw this entire column that you see here gets painted. That is why we return the value as 0 1 2 3 in this case. So this means that the moment we reach index 3, the entire column that we have here, which is at index 1, gets painted. Now this is what they want us to do. So if you take a look, right, what we've been doing so far is we have been painting cells, and for that we needed to know the rows and columns, because that's how we are locating each value in the array that they provided us. We were able to paint it because we knew the rows and column. We knew the rows and columns for that. So this is what we're going to do. We'll have a hash map. Create a hash map first, such that for each value it will store its rows index and columns index. We'll need that hash map to locate a value in this array right here. Whatever value comes next, we have to know its location in the matrix. That's part 1. So for that we'll create a hash map. For each value in the matrix, we will store its column and row value, basically its index, in a hash map. We'll create a row hash map which will have all the indexes, all the rows index of a value, and a column hash map that will have all the column indexes of a value. So once we have that, we'll be able to locate. Now how we will get to know that an entire column or an entire row got painted? How we will know that? Because that's the final check that we need to do before we return that R, basically this R that we are iterating here. First step is to locate the value in the matrix. The second step is to find if the entire row or a column got painted. So for this, again, what we're going to do is we will maintain a hash map for all the rows and all the columns. So what I mean by that is we will maintain a hash map for the rows 0s, 1 and 2, and what we're going to do with those values is and a similar hash map for column as well. So we were going to end up with having 4 hash map. In the second set of hash map that we have here, what we will do is with each index that for each value that we paint, right, we will since we know the index, since we know the rows and columns index for that value, what we'll do is at that exact column we're gonna do a +1. So what I mean by that is let's try to paint this again, but this time with all the hash maps that we have prepared. So if we go back and start coloring again, so as I said, what I'll do is first what we need to do is have hash maps so that we are able to locate the values. So for each value you're going to create a hash map. Each of these values in the matrix you're going to create a hash map, and in that hash map we will store the rows and columns index for that value. So with that, when we are iterating this array, we will be able to locate these values in that hash map. Once we are done with that, we will create another hash map having the rows and column values. So in one hash map we're going to store all the columns, the 0, 1, 2, and the other hash map we're going to store all the rows, which is 0, 1, 2. Now the moment we now in these what we're going to have is corresponding to all of these rows we're going to initially have a value 0, and corresponding to all these values columns we're going to have a value 0 in the hash map. With each cell colored, it's going to create an update. It's going to basically say that alright, we colored one cell for that row and that column. So in that row and that column we're going to do a +1. So if we take this example, right, firstly we colored the cell having value as in this one we had 2. So this is 2 right here. We colored the cell with value 2. So if we do that, what we are basically doing is we are coloring this value. So when this value gets colored, what this means is in the 0th row we have to do a +1, and in the first column we have to do a +1. That's what it means, right? Because a part of that row and a part of that column gets painted. So we update the values, and this becomes 1 and this becomes 1. This is and in order to do that we will need the index. That is why the first hash map is storing the indexes so that we are able to locate the values, and according to those indexes we are going to update the hash map of those columns as well, or rows and columns respectively. So we have updated 0 here 1 and then 0 here 1 because 2 got painted. So what this means that since this 2 got painted, it updated it kind of painted a part of the 0th row and the first column by 1. And how we will know that a particular row or a particular column got painted? Its value will eventually turn to 3. Like if you take a look at this example, what is the maximum value we can paint for each of these rows? 3. We have 3 we can paint. Same for this as well, same for this as well. The maximum we can paint is 3. So the moment with each update we're going to check if we reach that value. Same with column as well. The maximum that we can paint will be 3 right here, which is nothing but the number of rows that we have. For rows, it's for a particular row the maximum that we can paint is the number of columns, because if we had, let's say, one more column right here, or 3 more or 5 more columns, the maximum that we can paint for each row is nothing but the number of columns that we have. Same for all these rows. The maximum we can paint for each row is the number of columns, and same thing goes for the columns as well. The maximum we can paint for each column is nothing but the number of rows. For this column we can paint these many rows at max. So that is why we'll have to make that check. If this value right here that we are updating for each of the rows when the moment it becomes equal to the number of columns, will return that index R. So this is how the algorithm is going to work. So let's iterate this. We painted 2, so we found that alright, the 0th row a part of it got painted, and for the first column a part of it got painted. How did we know which row and which column? Because we are storing for each value we are storing its row and column indexes. That's how we are locating it. So 2 got painted, these values got updated to 1 and 1. We are at index 0. Now we are at index 1. We have to paint 8. Let's paint 8 now. So if we paint 8, we see that the 0th index here, so the second index here for row 2 and the column 0 gets painted. So we need to update this value and this value right here. So this gets updated to 1, the second row part of it got painted, and for the first column, the 0th column, part of it got painted. So far we haven't reached our answer because none of these values are equal to a row or a column. Now we come to the second index, which is index 2. We have to paint 7 now. Let's paint 7, and the moment we paint 7, we see that the second row here gets painted 2 now. So this is why this will get updated to 2, this gets updated to 2, because 2 cells are painted, 2 parts of it are painted, and for the column again, if you see, 2 are painted, so we need to update this. So far if you see, we have all the values correct. Like we have 2 painted here for the rows, like this row gets painted 2 and this row gets painted 1, and for the column, this column gets painted 1, this column gets painted 2. Now let's come to the next index, which is index 3. We'll have to paint 4 here, so let's paint 4. The moment we paint 4 right here, this gets painted, and we need to update this entire column now, since this got painted here, and this row also gets updated. So once we do that update, this will turn to a 3 and this will turn to a 1. Now the moment this turns to a 3, this indicates that this entire column got painted, and that is why that index 3, at index 3 we saw that entire column got painted. How we got to know that? Because of the count that we have been maintaining for column 1. It's now its value is 3. So the moment it turns 3 and this happened at index 3, so we are returning index 3. So this is how we painted this. Now let's do the same algorithm on the first example that we drew. This example, as I said, we will be maintaining a hash map where all these values will have their row and column, so that we are able to locate. That's one set of hash map for rows and columns for maintaining the indexes, so that we are able to at least locate these values in the matrix. The second set of hash map that we are going to make is for the rows and the columns. So in this case, we are going to have 2 rows, 0 and 1, and the maximum we can paint for each row is going to be nothing but the number of columns that we have. So the maximum this can reach is 3. The moment for any of these hash map values or 0 or 1, its value reaches 3, this would mean that this entire column got painted. If 0's value becomes 3, this means this entire 0th row got painted. If for this row 1 this value turns 3, this means this entire column row got painted. Same thing happens for column as well. If this value for the 0th column, this value turns 2, which is the maximum possible value, this would mean this entire column got painted. Same for this also. If this turns to 2, which is initially we'll set it 0, this column got painted. So I hope you are understanding how the hash map is going to help us. Initially these values are going to be 0. Now let's start coloring these values one by one. First we come at index 0, we have to paint 1. So let's paint 1, we painted 1. Now we see that this row, first row got painted, so we'll have to update this value. This value gets to 1, and this column, the 0th column, one value got painted, updating this value to 1. Now let's come to the second index, which is index 4. We have to paint 4 now. So in order to paint 4, let's do that. We see that this row here again got updated, because one of its part got painted right here. So you need to update this to 1, and this column again got painted, 0th column, and this has reached its final value now, which is 2. So we found that at index 0, 1, we saw that this entire column got painted. So this was the first index at which the entire column got painted. So that is why we are going to return 1 in this case. So this is how the algorithm is working. We're going to have 2 hash map, first set of hash map, which will help us to locate the values. In that hash map, we're going to do nothing but we're going to iterate the matrix. For each value, let's say 4, I'm going to store its index. It's going to store at which row it is present and at which column it is present, respectively, in the rows and the column hash map. In the rows hash map, we're going to store the row value, and the column hash map, we're going to store the column value. This will help us to locate each of these values that we are looking here, what index it is at. It was going to help us locate easily with this hash map. That's part 1. Once that is done, we're going to paint that. So how do we make the count of it? Again, another hash map will be required to check if each row or column reached its value threshold or not. So as we saw in the diagram, we will have a hash map for 0 value, 1 value, 2. This will be our first hash map for column. Each of these values will be initially 0 that we made here, and this will be our another hash map right here. This is another hash map. Each value of its value will be 0. For the R and C that we will be getting, we'll be updating those values in that particular row and that particular column by 1. The moment it reaches its threshold is when we'll return that R. So this is how the algorithm is working. I hope you guys are understanding. Now let's try to code this up. Now as I said, we'll need two sets of hash maps. Set 1 will help us to locate the value. So hash map row, this will help us, this will keep the track of the row indexes of a value, and hash map column will keep the track of what column index that value has. So let's quickly, and the other set of hash map is gonna be the threshold check. What is this will help us know if a particular row or column got painted or not. And then row is nothing but the length of the matrix. Now first step is to get the index for each of these values, right? The row and column index. So for that we'll need to iterate the entire matrix. Now for each value we are storing in the rows matrix. So and same for the column as well. What this line right here says is that in the first matrix, the row matrix, we are taking the value 3 and setting its row index to 0, and then again the second hash map we are taking the value 3 and setting its column index to 0. This means that the value 3 is present in the 0th row and the 0th column. This is what we are doing for each of these values. For each of these values we are setting its rth index for its which row is it present and which column is it present. So this will help us to locate the values once we are iterating. Once we are iterating this array that they have provided in order in which we have to paint, this will help us to identify in which row and which column each of these values are. This is why this hash map is doing. The second hash map is to check if the particular row or column gets painted or not. Now how do we know that? We will know that by getting the we will create another 0 1 2 0 1. So the number of rows, like we have 3 rows, right? We have 2 rows and 3 columns. So again, like this is why we are doing this check, like 0 1 2 and 0 1 is what we're going to do. So this is nothing will be the length of the row. For column is going to be the length of the row, and for the row it's going to be the length of the column. So that's why we are gonna do the same thing that we did. Initially all these values will be 0. So this hash map is nothing but what we created right here. For rows, it's gonna be this one. What is the value of row here? The value of row here is 2. So initially we're gonna have 0, 1, both of these values set to 0, and same for column as well. The column value is 3. We'll have 0, 1, 2, all these values set to 0. That's what we have done here. Row sum, col sum, that we defined here. Now what we need to do is simply we need to iterate the ARR array that they have provided. Now it's time to color these values. Now again we need to first find what is the value, what is at what index each of these values are, right? So we can find, so this is where this hash map that we created will help us. For each of these values we will get the row index, in which row and which column its value is. So we can update those count here in this hash map that we created. this will be ARR. This is how we are locating that value. So now what we have here is basically in each of this hash map row we basically stored that value and it's in which row it is. So we got that index. So this is the row, this is basically the location at which this value is. Now since we got that location, like in the case of first we saw its location was row 1 and column 0, right? That's why we painted here. Now for that row and that column we'll have to update the value 1 and 1 here. So this is why for that row, this hash map row sum gets, for that hash map row sum for that index R gets added 1, and the same thing happened with col sum as well. For that column the value gets updated by 1. This is basically what we are doing right here is this step that we did. We updated these values at the 0th index. When we painted 1, we updated this from 0 to 1 and this from 0 to 1. Now we need to do a check. After each update we need to do a check. Now what is the maximum that what is the max amount of row that we can paint, like this length right here, this length that right here, the maximum row that we can paint is nothing but the number of columns. That is why if at any point if this row sum becomes equal to the number of columns that we have, or at any point this col sum that we are having becomes equal to the number of rows that we are having, because the maximum we can paint a particular row, the maximum value that we can paint a single row is nothing but the number of columns, and the maximum value we can paint a particular row is nothing but the column. The maximum value we can paint a column is nothing but the number of rows that we have. That is why for row I am checking with the number of columns, and for the columns I am checking with the number of rows. I hope you are getting this point right here. The moment any of these value becomes true, this would mean that an entire row or an entire column got painted, and we'll just return that value R. So this is the entire algorithm right here. Let's quickly run these test cases, and the example that we just discussed, I have written it here. Let's run this now. Getting an indentation error. Alright, out of fixing all those errors, we arrive at this, and this right here that you see is what we are doing right here, the check that we are doing for a particular row or a particular column. For a particular row index or a particular column index, the value becomes equal to that or not, that we just discussed. For a row, the maximum that we can paint is nothing but the number of column. So for each row index, which is 0 or 1, if at any point the value becomes 3, that would mean the entire row is painted. Same goes for column. The maximum we can paint for a column is 2. So for any column which is like 0, 1 or 2, if its value turns out to be 2, that would mean that entire column got painted. So this is what we are doing here. For any value in that row sum, for any 0th row or for the first row or the nth row, if its value turns out to be a column, or for any column at any index, for any column, the 0th column, first column or the nth column, its value becomes equal to row, this would mean that entire column got painted, and that's when we return the R. So if you run this, as you see, it's all passing all the test case, and if you try to submit this, this is the final runtime. And if you try to take a look at the time complexity of this problem, this will be a O of m cross n plus O of n, O of R, you can say, whatever the length of the array that they provided here. That array length goes up till both are between that m to n range. So having said that, the m cross n comes from the first iteration that we are doing for storing the row and column so that we can locate, and the second iteration is again for the row and column, and the third iteration is for the entire array so that we can get the values. And that was it. I hope you guys like this video, and I'll see you in the next one.